So let's see the preparation of aldehydes. So you can prepare the aldehydes using the acyl chloride. So we'll see what is this acyl chloride. You can do from nitriles and esters. You can do from aromatic hydrocarbons. So these are the three different ways by which you can prepare aldehydes. So let's see the first one from the acyl chloride. So this acyl chloride is also known as the acid chloride. Remember, this acyl chloride, it is also known as the acid chloride. Okay. So what is this acyl chloride? Hydrogenation of acyl chloride over a catalyst, that is palladium on barium sulfate, gives aldehydes in a reaction known as the Rossmann reaction. So just remember, this is a very, very, very important another named reaction, that is a Rossmann reaction. Okay. So what this reaction says? This reaction says, first suppose you take a acyl chloride. First suppose you take an example. Okay, let's say you take a acyl chloride. With the help of hydrogenation, you can convert that into the aldehydes and hydrogen chloride. Okay, so hydrogenation of this acyl chloride over a catalyst, that's a palladium on barium sulfate, gives the aldehydes. Okay, so let's take a good example. So let's elaborate this structure. So in the presence of palladium, barium sulfate. Not only that, you need another here, that is the tertiary amine, which is R3N. Okay, so that finally gives, what is this structure? Aldehydes. Okay, so what we are doing here, we are doing the hydrogenation. This is very important. Okay, so we are doing the hydrogenation. So if you see here, what does the reaction requires here? An acyl chloride is needed. You need an hydrogen gas. So what does this hydrogen gas will do? It will act like a reducing agent. Okay, this will act like a reducing agent. And you need a catalyst. The catalyst here we are using is palladium on barium sulfate. Okay, so we will be using the palladium on barium sulfate, which acts like a catalyst. Apart from that, we are taking a tertiary amine. So if you see here, there are three R groups are there, which is attached to the nitrogen. So this is a tertiary amine. So what is this tertiary amine? It is also catalyst. Okay, so that will give the aldehydes and hydrogen chloride. There's an important thing here. So this reaction is this reaction proceeds in a very controlled way. Okay, so why we are doing? Because whatever the acyl chloride is there, it will reduce to aldehydes, but it will not further reduce to alcohols. That is very, very important. So whatever the acyl chloride is there, it should reduce up to the aldehydes. It should not further reduce to alcohols. It should not. So it should not further reduce to alcohols. Understood? So what we are doing here, the preparation of aldehydes using the acyl chlorides, and this reaction is known as the Rosen-Mundt reaction. Just remember, this is known as the Rosen-Mundt reaction. Okay, so what we are doing here, we are taking the acyl chloride, we are taking the hydrogen gas, which acts like a reducing agent. We are doing the hydrogenation here. Okay, and there is a catalyst, that's a palladium on barium sulfate, and you are taking a tertiary amine. Okay, so this tertiary amine is a poison for this catalyst. That means it will only do the reaction to some extent. It will not proceed the reaction till the conversion of alcohols. It should stop till the aldehydes. It should not further reduce to alcohols. It should not. Understood?
Yes, sir.
Is it
Sir, could you repeat the last part again?
So if you see here, the acyl chlorides, they should convert into aldehydes, but they should not further reduce to alcohols. It should not happen. Okay. We want to stop the reaction here. We should not want to continue up to alcohols formation. Okay.
Then how do you stop it?
That's how we will be using this R3N. This acts like a poison to the catalyst barium sulfate. So the barium sulfate will be degraded and you will not be having this catalyst. So the reaction will not proceed further. And
So,
whatever the, yeah,
so if R3N is not there, it'll turn to alcohol.
yeah,
Okay. Okay.
okay, okay. So next one, Stephen reaction. So the next named reaction. Guys, remember the named reactions are very, 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 very important. So just now itself you learn. Okay. So what is this Stephen reaction? Here we are converting the nitriles to aldehydes. Okay, so what are nitriles? R C triple bond N. So this R C triple bond N, we call it as the nitriles. Okay, so these nitriles you are converting into the aldehydes. So this conversion of nitriles to aldehydes, we call this as a Stephen reaction. Understood? So what is Stephen reaction? It is a method of converting the nitriles RC triple bond N, which is a cyanide group, into an aldehyde is called as the Stephen reaction. So reduction of a cyanide, which is nothing but a nitrile, is carried out with acidified stannous chloride, that is SnCl2 and HCl at a room temperature. Okay, so then an intermediate will be formed, that is imine hydrochloride will be obtained. And finally, on hydrolysis with the boiling water, it will give the aldehydes. So if you see here, the reaction follows two main steps. One is the formation of the imine chloride. So what is the first main step? The first main step you see here is the formation of imine chloride. Actually, it's a imine hydrochloride. And what is the second main step? Hydrolysis. The second main step is hydrolysis. So what happening in the formation of the imine hydrochloride? Whatever the nitrile that you are taking, it is reduced by a acidified stannous chloride. That is SnCl2 HCl. So here HCl acts like a acidifying agent. And SnCl2, that is stannous chloride. And that's taking place at the room temperature. Okay, so when you do that, it will give an intermediate that is called as the imine hydrochloride. This imine chloride, you hydrolyze it, that means you break down it with the help of breaking the water molecule, that will give the final aldehyde. Understood? So the reaction will happen this way. You take a nitrile, R, C, triple bond N, this in the presence of acidified stannous chloride. That is what the first step takes place. And the second step is hydrolysis. And that finally gives the aldehydes. Understood? So I told here, then there is a imine hydrochloride. Just know this imine chloride, hydrochloride, it is like this. RCH. You don't need to remember this, I'm just giving it. But just know its name. It is called as the imine hydrochloride. So this is known as imine hydrochloride. Understood? Is it clear?
Yes, sir.
Yes, sir.
Next
Yes.
one, by Debal H. Okay, Debal H. So what is this Debal H? It is a diisobutyl aluminum hydride. Okay. So what is this? Diisobutyl aluminum hydride. So it is diisobutyl aluminum hydride. Okay. That is nothing but AlHiBu2, which is acting like a reducing agent. So just remember. So what happening here? Dibal H is a less reactive than lithium aluminum hydride. It is more sterically hindered and has difficulty in transferring hydride ions. So also know this. Okay. So just know what this dibal H will do is it selectively reduce the functional groups. Particularly when you take the nitriles esters, those nitriles and esters, it will convert into the aldehydes and it will stop at the aldehyde stage. It will not further convert into alcohols. Okay. So what is the specialty of this dibal H is it will selectively reduce. It will reduce only the nitriles and esters and it will reduce up to aldehydes. It will not continue to alcohols. That is the important thing. Okay. So just know that. You just know this. Okay. What it will do, whatever the dibal H is there, it will selectively reduce. Selectively reduce only certain functional groups. Okay. So what are those certain functional groups? It could be the nitriles and esters. Okay. Just a second. Okay. So how does this dibal H looks? You just know it. You don't need to remember the structure, but just know. So this dibal H looks like this. So this is a diisobutyl aluminum hydride. Diisobutyl aluminum hydride. So the reaction will follow like this. CH3C triple bond N. What is this? It is a nitrile. So this nitrile in the presence of dibal H at 25 degrees Celsius, this will be converted into an aldehyde. So what is this? It is a nitrile group. And what is this? It is a aldehyde. So if you see here, I told you, so either nitrile or ester will be converted up to aldehydes. It will not further convert into the alcohols. That one also you should remember here. So this one will not convert, or you say will not further reduce to alcohols. Stops at aldehydes. Okay, so that's what selectively reduce certain functional groups, nitriles and esters that will reduce up to aldehydes. It will not further reduce to alcohols. Okay, so you can see here nitrile group has converted to the aldehydes. You take another example that's showing the ester. So let's see ester C6H5 C double bond O, OCH3. What is ester? R, C double bond O, O, R dash. So this is called an ester. Just remember, if you don't know what is ester. So this ester, in the presence of diol H, I'm putting DH at 78 degrees Celsius. And we need another thing here, the toluene is also needed. Okay, it also requires the toluene. It will convert into C6H5CHO, which is a aldehyde. So you can see here, ester will convert into the aldehyde. Understood? So what is this? It's the preparation of the aldehyde by using the diisobutyl aluminum hydride. So what it do? It acts like a reducing agent. It is a very selectively reduce only certain functional groups, that is nitriles and esters, and it will reduce up to alcohol. It will reduce up to aldehydes. It will not further reduce to alcohols. Okay. So whatever the nitrile groups are there at 25 degrees Celsius in presence of this diol H, they will convert to aldehydes. If esters are there at 78 degrees Celsius in presence of toluene, they will convert to aldehydes. Is that clear?
So,
Understood?
so could you, yeah, 1 second.
Right, Ganda?
1 second. That's it.
Okay. The next one. What will be the major product of the following reaction? Tell me, what will be the major product for this following reagent? At least tell me by looking at what is this reaction or what is the reactant here?
Nitrile.
Yeah. So nitrile will reduce to if whatever the structure you are seeing here, don't confuse it is a diol H or not. It is diol H only. Okay. So whatever you are seeing here, whatever that is here, the aluminum hydrogen isobutyl. So this is nothing but diol H. So what we'll get? Diol H, hexane. So what you will get?
Aldehyde.
Aldehydes. Okay. So you simply remove this CN and you put the aldehydes here. You remove the N here and put double bond OH. So that's it. That will be the answer.
So why hexane?
Hmm?
So why is hexane also that?
Hexane acts like a catalyst. We saw now there. Toluene we used. Toluene is nothing but what? Hexane with CS3, right?
Yes.
Yes, sir.
Okay. So here that acts like a catalyst. I mean, if you want to know why clearly the hexane is needed, then I need to pull out the mechanism for this. But here they don't give that mechanism, and also I'm not dwelling deep into why the hexane is there. So just know it is a catalyst. Okay.
Okay, sir.
Actually, if you want to know clearly why the hexane is used, if you remember, we discussed about the polar solvents and apolar solvents. So why does some solvents, polar solvents will be helpful, some non-polar solvents will be helpful? We saw, right? Based on the charges. I think I told you in the alloalkanes and alloarenes, if you remember or not. Do you remember polar aprotic solvent, polar protic solvent? Tell guys, you guys remember or not?
Kind
Are
of.
Shrikar నీకు గుర్తుందా?
Kind of. Yes, yeah.
Nitya, Mandara, do you remember? I told you at the time why we use the polar and apolar. Huh?
I
Nitya?
heard his name, sir, but I don't remember what it was.
Mm-hmm. I told you now in the reactions, the using of the protic solvent and aprotic solvent, some will try to depolarize the charges and slow down the reactions. Nitya?
Sure.
Yeah. Anyways, so what is the use of this hexane is actually this hexane acts like a non-polar solvent. Okay. So when it is a non-polar solvent, it will selectively reduce. Okay. It will be helpful to maintain the selectivity of the reduction, you can say. Okay. That means whatever the reduction is happening, it will happen up to the aldehydes. It will not further convert into amines. What happen if we don't use this hexane and all? What happen? This will strongly reduce to aldehydes, and this aldehydes further strongly reduce to amines. Okay, so here the use of this hexane is to maintain this selective reduction. That means whatever the reagent is there, it will convert into the aldehydes. It will not convert into the amines. Okay, it will prevent the conversion into.
Sir,
It will
alcohol
prevent.
amines?
Huh?
Sir, is it alcohol amines?
No. Conversion of aldehydes to, it could happen to further alcohols. But here the cyanide is there, na? N is there, and can convert into amines.
Okay, sir.
That's why I removed here and I kept directly here. So this is another pathway. So if you see here, the major product is said. Why? Because it can convert aldehydes and a little amount it can convert to amines. Understood?
Yes, sir.
Yeah. So just know here. So whatever the reagent that we are using here, it's a dibal H. Okay. And what does this dibal H will do? Just know this. What does this dibal H will do? Reduce cyanide, which is nothing but a nitrile group, to aldehydes only. Okay, it will not further reduce to alcohols. That's one thing. Okay, and whatever the non-polar solvent is there, it will maintain selective reduction. And the other thing is, you should know here, whatever the double bonds are there, those double bonds are not disturbed here. Okay, so that is another thing you should know. So whatever double bonds are there, double bonds are not disturbed. Or you can say whatever the alkenes are there, those alkenes will not be affected. You can also say it that way. Alkenes will not be affected. So what will be the product will be formed here? This will look somewhat like this. Okay. Understood?
Yes, sir.
Yes, sir.
Only two understood.
Yes, sir.
Next one. Consider the following reaction. Come on, guys, quickly tell. We are still at the slide 7. Tell me what will be the product? A.
Sir, option A.
Sir,
Yes. What is this reaction name called? What is this
Roseman
reaction?
Ethan.
Yeah, this reaction is called Rosenmund
Okay.
reaction. Okay, so in Rosenmund reaction, what happens? Whatever the benzoyl chloride is there, this is called the benzoyl chloride. Okay, that will be converted into the benzaldehyde. Okay, that happens in the presence of the hydrogen. So hydrogenation, palladium, barium sulfate. Okay, so it's nothing but like this. Next one. So from hydrocarbons, how do we prepare the aldehydes? So preparation of aldehydes from hydrocarbons can happen through 3 ways. One is by the oxidation of the methylbenzene, by side chain chlorination followed by the hydrolysis, and the Gutterman-Koch reaction. This is very, 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 very important. It's a named reaction, so very important. So if you see the oxidation of the methylbenzene itself, there are 2 ways. By using the chromic oxide, that is CrO3, by using the chromyl chloride, CrO2Cl2. So these are the 2 ways through which we can prepare the aldehydes by using the methylbenzene. So let's see how do we do that. So first one, by using the chromic acid. Okay. So let's see what is this. By oxidation of the methylbenzene acid and its derivative using the chromic oxide in acetic anhydride. Okay. So what that means, what we are taking here, we are taking the methylbenzene or else whatever the compounds that are derived from this methylbenzene. So this methylbenzene, by using the chromic oxide in the acetic anhydride, we are converting that into an aldehyde. Understood? So this reaction will happen in 2 ways. One is, just know, I'll tell a little bit mechanism. So first what happens is oxidation. So with the help of this CrO3, okay, oxidation with CrO3, that is chromium oxide and acetic anhydride. Okay, so let's show the reaction. So you take a benzene, that benzene with a methyl group. So what do we call this as?
Tolling.
Yeah, it's a toluene, or you can call it as the methyl benzene. Okay, so this methyl benzene and the chromium oxide, CrO3, and acetic anhydride, that is nothing but CH3CO2O. This is called as acetic anhydride. That's made up with the acetic acid, CH3COH, CH3COH. You remove the H and OH and you join these two. That will give the acetic anhydride. Okay. So you will be removing the water molecule from that. that will convert into the acetic anhydride. So in the presence of 273 to 283 Kelvin, it will give the benzene with OCOCH3 twice. You don't need to remember this intermediate compound, okay? But if they ask, you call this as a diacetate intermediate, okay? So this is called as diacetate, which is an intermediate molecule. So this diacetate intermediate will further undergo the second thing. The second thing is called hydrolysis. So there will be hydrolysis will happen. So here H3O plus will happen. Okay, and there is a use of temperature. So that will be converted into the aldehyde. Okay, so what happened here? Whatever the methyl group is there that is attached to the benzene ring, it will undergo oxidation in the presence of this chromic oxide and acetic anhydride. What happened here? Whatever this methyl group is there, this will undergo oxidation. Okay. So that will result in formation of a diacetate intermediate. You can see here, this is a diacetate. You can see here, twice is there. That means two acetate groups are attached. And there is a anhydride. So diacetate anhydride. So this is called as diacetate. And whatever the methyl group is there, that will be converted into this diacetate. Okay. And this is followed by the hydrolysis. Okay. Whatever this diacetate is there, it will be hydrolyzed in the acidic medium. Just remember this. H3O plus is nothing but acidic medium. Because if you see this H3O plus, it can able to donate the proton. It can able to donate the proton. So that's why this is called as the acidic medium. We know acids are nothing but the proton donors. So here it can donate the proton and it can form the water molecule. So that's why this is called as the acidic medium. Okay, if you don't know why it's called as the acidic medium. So because of this acidic medium, whatever the acetate is there, it will be removed and that will be converted into the aldehyde. So you just remove this part and you put the hydrogen here. Whatever the proton is donated, that proton will attach here. That's how it will be converted. Okay. I mean, I didn't explain in detail, but yeah, somehow it will happen that way. So just I'm quickly repeating, just see here, whatever the methyl group is there, it will be oxidized with the help of chromic oxide in acetic anhydride at 273 kelvins, and that will be converted into the diacetate intermediate. So followed by the hydrolysis in acidic medium, that will give the aldehyde. So this is called chromic oxide, using aldehydes preparation using the chromic oxide. Understood?
Yes, sir.
Yes, sir.
So again, Shrikar and Mandar understood. Is Nitya in the class?
Sir, I got disconnected.
When I'm asking question to you.
No, sir, seriously, I disconnected, sir. I joined in phone now. Sir, can you
What
repeat the
happened,
question?
Nitya? You don't have Wi-Fi? Always you are facing this issue.
Sir, I have Wi-Fi signal does not come properly. That's the problem.
Which Wi-Fi you are using?
Geo.
Geo. Geo is waste, Nitya. Switch to Airtel.
Okay, sir,
just
I'll
a
tell
sec.
my phone.
Hmm?
Okay, sir. So what was the question?
You understood. How you understand, Nitya? You are switching the mobile's internet. Anyways, so just see this. I'll just come. I'll drink some water and come. Okay, so the next one is the Etard reaction, another named reaction. So here we'll be preparing the aldehydes using the chromyl chloride, that is CrO2Cl2. Okay, so in the previous we used the chromium oxide, CrO3. In this we will be using the chromyl chloride. So what is this Etard reaction? So it is a method where you will be preparing the aldehydes from the methyl substituted aromatic compounds. Okay. What is meaning of methyl substituted aromatic compound? What is the name of that compound? C. Methyl substituted aromatic compound. It's nothing but methyl benzene, which is toluene. Okay. So this toluene you will be using in this. Okay. And you will be using the chromyl chloride, which acts like a oxidizing agent. So just know this. So here the the chromyl chloride will be acting like a oxidizing agent. Okay, so let's see how does this reaction will happen. So you will be taking a toluene group in the presence of CrO2Cl2. This will be converted into in the presence of CS2. What is called CS2 as? Shikhar, CS2 అంటే ఏమంటారా?
Cesium something. Cesium, right?
సీజియం రా. ఇక్కడ సి అంటే కార్బన్ రా. సీజియం ఎక్కడి నుండి వచ్చిందిరా? కార్బన్ డైసల్ఫైడ్.
CS2 అన్నారని.
నోటికి వచ్చింది చెప్పు. See, they will not give this way. Sometimes they can also give C6H5CS3. You should be able to tell it's a toluene. Okay. So I'm mostly representing the structures, but you should also know the formula. Okay. So this is a toluene and this is a chromyl chloride. And this is carbon disulfide. And this is chromium complex. And this is benzaldehyde. Okay. So now see here. So this reaction will takes place in two steps. Okay, like we saw before. So first one, what happens? There will be formation of this chromium complex, which is an intermediate. So the first one is formation of chromium complex. You don't need to remember all this. Just remember this chromium complex contains somewhat structure like this. Okay, they will not ask you this much big structures, but at least you should know the names. Chromium complex. Second one, hydrolysis. So whatever the previous thing we studied, the same way it happens here. Okay, what happens here? Whatever the methyl benzene is there, that will react with the chromium chloride in the presence of carbon disulfide, and that will form a chromium complex. Okay, so this methyl group will be reduced to this chromium complex. Okay, so that toluene will convert into this chromium complex. Now, this will be followed with a hydrolysis. Okay, so in the presence of water, that will be converted into the benzaldehyde. That's it. You remember this much. So toluene is there with the help of chromium chloride in the presence of carbon disulfide convert into chromium complex intermediate that will further hydrolysis and convert into benzaldehyde, or in the presence of water converts into benzaldehyde. That's it. Understood?
Yes, sir.
Yes, sir.
Okay. So next one, by side chain chlorination followed by hydrolysis. So what happened here? Side chain chlorination of toluene will happen. That will convert into the benzyl chloride. That will convert into benzaldehyde by hydrolysis. This is another way. So you see here, first you take a benzene with a methyl group, that is toluene, in the presence of chlorine and HV, sunlight. It will convert into CHClCl. Okay, this will undergo hydrolysis at 373 Kelvin and convert into benzaldehyde. That's it. Understood? So first, what happened? Side chain chlorination of toluene will happen. Whatever the toluene is there, you remove the hydrogen, you put the chlorine. So like that, you will be removing two hydrogens and you will insert two chlorines. So that's how it will turn out to be CH2 CHCl2. And you do the hydrolysis at 373 kelvins at 100 degrees Celsius, it will convert into CHO. I mean benzaldehyde, aldehyde group. Next one, the very most important named reaction, Gutterman-Couch reaction. Okay. This is a very simple reaction. So what happened here? Conversion of aromatic hydrocarbons and allobenzenes into benzaldehydes. Okay. So what happened here? You take a benzene or you take a benzene derivative like allobenzenes. That means the benzene ring substituted with a allo compound in the presence of COHCl, anhydride AlCl3, copper chloride. It will convert into the benzaldehyde. That's it. The reaction is very simple. Okay. So what are the reactants we are using here? We are using the aromatic hydrocarbons. Okay. What is the aromatic hydrocarbons? It is the benzene or its derivatives. And we are using the carbon monoxide. We are using carbon monoxide. We are using hydrogen chloride. So these two will act like a reagents. And we are using the catalyst. Here the catalyst is anhydrous aluminum chloride. Okay. Sometimes we can also use the copper chloride, or you can say the copper 1 chloride. And that will be giving the products, which is the benzaldehyde or sometimes substituted benzaldehyde. If you take here substituted benzene, it will give substituted benzaldehyde, which is also a aromatic compound. Understood? So the aromatic compound that will convert into the benzaldehyde, it's nothing but the Gutterman-Koch reaction. Any doubts? If you want to know the mechanism, how it will happen. So what happened here is the carbon monoxide and HCl, they react in the presence of this aluminum chloride or copper chloride. And they will form a reactive intermediate. That intermediate is like a electrophilic species. That electrospecies, which will be formed by this copper monoxide and HCl in the presence of this catalyst, that will react with the aromatic ring that is present here. Okay. So they will substitute one hydrogen atom on this ring and form a CHO, that is a benzaldehyde. Okay. So they will first form a formal group. That formal group will finally turn into the benzaldehyde. So I'm not getting into detail, but just know what are the reactants and what are the products, what are the catalysts here. Understood?
Yes, sir.
Yes, sir.
So just know what are the reactants and what are the products and what are the catalysts are used. We don't need to study all the mechanisms for every reaction. So next one, tell me what would be the answer. So this reaction, just now we talked the first one. In the presence of carbon monoxide, HCl, in the presence of anhydrous aluminum chloride.
Yes, sir. Option
So reaction by which benzaldehydes cannot be prepared.
Option B, sir.
Yeah, option B. You can prepare by this method. You can prepare. So this will not be our. You can prepare by this method. What is this method? What is the name of this reaction?
Attard reaction.
Yeah, it is a Etard reaction. I think only Nitya is writing the notes. What about the others? What about this
Right,
reaction?
sir.
Rosenmund reaction.
Yeah, it is a Rosenmund reaction. So we know from the Rosenmund reaction also we can prepare the benzaldehyde. From Etard reaction we can prepare the benzaldehyde. From Gutterman reaction we can prepare the benzaldehyde. But we cannot prepare with this reaction. Okay. So actually this is a carboxylic acid, and this carboxylic acid will not react with the zinc mercury, which is a zinc amalgam, actually it is called. Okay. So benzaldehyde cannot be formed by this reaction. So this is our answer. Next one. Okay, leave about this. You guys do this. I'm not gonna tell you this. Next one. See, these are all reactions which we studied before. So I'm not getting into it. Next one. Tell me this. Reduction of benzoyl chloride with PD and BSO4 gives. What is this? What is this reaction name? Tell me. Where do we use the PD and BSO4?
Rosenmund reaction.
Yeah, we are used in the Rosenmund reaction. Okay. If you remember what happened in the Rosenmund reaction, there is a benzene with a CO double bond OCl. That is what the benzoyl chloride. In the presence of hydrogenation, palladium, barium sulfate, that will be converted into the aldehydes. Okay. So here, what will be the answer here? Option
B.
B. Next one. Benzaldehyde can be prepared by the hydrolysis of. So where do we use it, the hydrolysis? First of all, okay, benzonitrile. So we saw benzonitrile, that is a cyanide group. By using the cyanide group, we get the benzaldehyde. That's okay. So let's put it here. Let's put it this aside. So benzo trichloride, benzo chloride. Have we see the benzo trichloride or benzo chloride that is giving the benzaldehyde by hydrolysis?
Yes, sir.
So we didn't see. So we can easily eliminate these two options. Next one, benzyl chloride. What about this benzyl chloride? Which is nothing but C6H5 CHCl. If you remember, I told you either you use the benzene group with a toluene or you use the toluene substituted, which is nothing but CH2Cl. That is what the benzyl chloride means. So benzyl chloride means simply, so sorry, it is Cl2. Do you remember this one? Where do we use?
Gutterman. Gutterman-Koch reaction.
Gutterman Koch reaction? Nope. Remember? Where do we use CHCl2? Somewhere I think I have given you the example, na? One second. Mm-hmm. One second, guys. See here. You can see here. CHCl2. Is that our example, right? Benzyl chloride. Yes or no?
Yes, sir.
And we did the hydrolysis and it has given the aldehyde group. So by side chain chlorination followed by hydrolysis. Okay, Nitya? I was just finding for this example.
Yes, sir.
Yeah. So benzyl chloride. So here we can clearly saw the benzyl chloride has undergone the hydrolysis and it has turned out to be the benzaldehyde. Now come back to the benzonitrile. In the benzonitrile, did we do so benzonitrile, that is nothing but a Stephen reaction? Did we do the hydrolysis? It will give the benzaldehyde. But in that reaction, when we took the cyanide, did we do any hydrolysis there?
No, sir.
Yeah. So this is not by hydrolysis. It will give, but not by hydrolysis. So the option is only the D. Even the A is not a answer. Clear? Next one. So this is a Stephenson reaction. You can see clearly here. Okay. So CH3CH2C triple bond N in the presence of what catalyst that will be converted into this.
Is it option A?
Option
Yeah. SnCl2 HCl, water, and then we did the boiling. Next one. So which of the following reagents is used to convert ethane and nitrile? Ethane and nitrile to ethanol.
Option D.
The answer is D. We use the dipal H. What is this reaction called?
Stephen reaction.
Stephen reaction. Next one. What will be the answer? Bute 1-ine. So I'll write you bute 1-ine. So you take the carbon, carbon, triple bond, carbon, and carbon. So bute, 4 carbons. On the first carbon, there's a triple bond is present. So bute 1-ine. So in the presence of water, sulfuric acid, and SgSO4. Actually, this is yesterday's class. So what it will give? If you remember, this will give a kind of alcohol group. And then this will be followed with a tautomerization If you don't understand this, just go back to yesterday's class and see there. So that will convert finally into CH3, CH2, C, double bond O, CH3, which is nothing but a ketone group. So answer D is the correct. If you don't understand what is this, just go yesterday's class. We studied this in the yesterday class. Next one. The same, whatever the before one I told, the same one. We use the HgSO4 and H2SO4. If you remember, see here, in the presence of HgSO4 and H2SO4. But here, the H2SO4 should be 20%. I didn't mention yesterday. So just make sure it is a 20% H2SO4 plus HgSO4. Okay. Next one. Predict the product of the following reaction. So PaCH2OH, PCC, that's nothing but pyridinium chlorochromate in presence of CH2Cl2. If you remember, yesterday the first we talked, it will give aldehyde. But the aldehyde is not on the benzene group. It is on the here. Okay, actually, sorry, this is not. One second. So here the carbon, which is directly attached to the benzene. And now the whatever the aldehyde group is directly attached to the benzene group. So the answer will be the benzaldehyde. Understood? See, this is all yesterday's class. That's why I'm not explaining in detail. Because yesterday we did these kind of examples. Next one. So which of these compounds will give formaldehyde as one of the product on ozonolysis? Do you remember? We did the ozonolysis. And I especially mentioned about the formaldehyde. So which compounds will give the formaldehyde? If you remember, I told you there is a two kinds of alkenes, terminal, non-terminal, if you remember. And in that condition, I told you only the terminals will give the formaldehydes. And non-terminals will give the ketones. So which one will be the formaldehyde here? By the product of ozonolysis.
Sir,
Hmm.
terminal is the end of the carbon thing, right?
Yeah. So which one is having double bond at the end? I mean, on the first carbon.
Option D.
Option?
D. No, sorry, B.
అరే నేను ఇక్కడ పెట్టానని చెప్పేసి ఇది అవుతుందా?
No, I said B, end.
B. So if you see here, the first carbon is this, and this is present at the end, at the terminal carbon. Terminal carbon means the first carbon or last carbon. So this will be the option. If the double bond is present in these conditions, it will turn out to be the ketone. But if it is present at the end, it will turn out to be the aldehyde. Just know it. So the terminal will become the formaldehyde, the non-terminal will become the ketone. Remember this. Next one. The major product of the following reaction is do you remember? Yesterday I told you the attachment of the OH and the attachment of the hydrogens. First hydrogen and OH. Where does that will happen? Hydrogens will attach where the number of hydrogens are more. But if you see here, both the carbons are having same number of, okay, they are having equal. They are like equal, identical. So we cannot talk about that. And then I told you, so which one is heavier? For suppose if you see this is only present this much, but if you see this much plus this much. So if you see the right side is more heavier. When the right side is more heavier, the OH group will go and attach to this. The hydrogen group will go and attach here. So that will turn out to be the double bond. And whatever the bond is broken here, that will lead to attachment of hydrogen and OH. And there is another bond is present. Out of three bonds, one bond will be eliminated by attachment of hydrogen and OH. The other bond will be eliminated by attachment, by conversion of this OH. See, this will happen like this. First of all, there is a 3 bonds are present. On my right side, it is a heavier group. On my left side, it is a lighter group. For the lighter carbon, the hydrogen will attach. And on my heavier group, the OH will attach. So by attachment of this OH and hydrogen will remove one bond. Now 2 bonds are there. So now how does these 2 bonds will convert is whatever the oxygen and hydrogen are there, they will break up. Okay. And this hydrogen will go and attach to this carbon. Okay. It will go and attach to this carbon. So by attachment of this hydrogen, one bond will be broken. Now it will be O minus. And here this is a also. So this will try to make, this is plus. So this will try to make the bond here and this will turn out to be like this. Understood? So that's how this reaction will be like this. You understood how this came? If you understand, tell me, otherwise I'll explain it again. Yesterday we talked about how this conversion will happen.
So could I repeat once?
See, here how the triple bond will be converted into single bond. That is the main thing. Okay. So just know here, first suppose, let's say this is a lighter group, carbon, triple bond, carbon, heavier group. Instead of this all, I'm just putting as a heavier group. And I'm mentioning that on my right side, the heavier group is present. On my left side, the lighter group is present. So to the carbon, now whatever the H and OH are there, to the carbon which is having lighter group, the hydrogen will go and attach. Here the lighter group is this carbon, so hydrogen will go and attach here. Okay. So let's see, this reaction will happen like this. So lighter group, carbon, double bond, carbon, heavier group. So hydrogen will attach here and OH will attach here. So that's how the triple bond is converted into the double bond. Now the further conversion will happen by breaking the bond. So how does the bond breakers will happen is whatever the OH is there, the bond will break between the OH and this hydrogen will go to this carbon. So the reaction will be like this. So lighter group, carbon, hydrogen. So this hydrogen will go and attach to this hydrogen. There will be single bond, carbon. So you see here, whatever the double bond is there, now it's broken. Because the carbon can only attach to 4. So if the other hydrogen is attached, now it will become 5 bonds. So that's a very difficult. So the carbon will break the double bond here. So when it is broken, this carbon will get the positive charge and the oxygen will get the negative charge. And there is a Hg. Now this, whatever the negative charge is there, it will try to make a double bond between the oxygen and carbon. So lighter group, carbon, hydrogen, hydrogen, C, double bond O, Hg. Understood now? So now instead of this lighter group and heavier group, you put these benzene rings. So that will be our answer. Is it clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So the last question now. See here. Now you tell me how this will happen. Send me the photo in WhatsApp individually. Here pH means the phenol group. So how do you convert that triple bond into single bond?
Sir, I sent.
Yeah, Nitya, it is correct. Can you name it?
I'll do it. Sir, I sent.
Correct, Nitya. What about your Shrikar, Mandara?
Sir, 1 second. Sir. Sir, I'm not getting, sir.
ఒరే ఏముందిరా ఇందులో లెఫ్ట్ సైడ్ హెవియర్ గ్రూపా రైట్ సైడ్ హెవియర్ గ్రూపా చెప్పు
Left side.
ఆ కార్బన్ కి డబుల్ బాండ్ ఓ పెట్టు ఇంకో కార్బన్ కి హైడ్రోజన్స్ పెట్టు అంతే ఇక్కడ మనం ఏం చేసాం చూడు లెఫ్ట్ సైడ్ ది స్మాలర్ గ్రూప్ రైట్ సైడ్ ది హెవియర్ గ్రూప్ సో ఈ కార్బన్ కి నేను డబుల్ బాండ్ ఓ పెట్టా ఈ కార్బన్ కి హైడ్రోజన్స్ పెట్టాను అంతే ఈ ఎక్స్ప్లెనేషన్ నేను చేశాను ఎలా ఇక డబుల్ బాండ్ ఓ వచ్చింది ఫస్ట్ ఓహెచ్ గ్రూప్ అటాచ్ అయింది తర్వాత అది ఓ మైనస్ అయ్యింది తర్వాత అది డబుల్ బాండ్ ఫామ్ చేసింది నేను ఇది ఎక్స్ప్లెయిన్ చేశాను
Okay, sir.
ఇప్పుడు ట్రై చేయి మందారా ఇస్ మందారా ఇన్ క్లాస్
Yes, sir.
So maybe she went to get the phone.
ఓకే
Sir, even CH3 will get attached.
ఏంట్రా
So CH3 will get attached to the other end.
సిహెచ్
3.
అవన్నీ ఉంటారా ఇక్కడ చూడు ఇక్కడ ఏదైనా మిస్ అయిందా నీకు
No, sir.
ఈ కాంపౌండ్కి చూడు సో ఇక్కడ ట్రిపుల్ బాండ్ ఒక్కటే మనం రిమూవ్ చేసాం వాట్ ఎవర్ ద 3 బాండ్స్ ఆర్ దేర్ వీ కన్వర్టెడ్ ఇంటూ సింగిల్ బాండ్ బట్ అది ఎలా కన్వర్ట్ చేసాం ఆక్సిజన్ పెట్టడం వల్ల కానీ నేను ఆక్సిజన్ ఎటు సైడ్ పెట్టాను అనేది అది ఎవియర్ గ్రూప్ వైపు డిసైడ్ అయ్యి ఉంటుంది ఇక్కడ నా లెఫ్ట్ సైడ్ నా రైట్ సైడ్ ఎవియర్ గ్రూప్ సో అందుకు నేను సి డబుల్ బాండ్ ఇక్కడ పెట్టా లెఫ్ట్ సైడ్ అనేది లైటర్ గ్రూప్ అందుకే నేను హైడ్రోజన్ సిహెచ్2 అని పెట్టా అండ్ యాజ్ ఇట్ ఈస్ వాట్ ఎవర్ ద అదర్ స్ట్రక్చర్ ఇస్ దేర్ ఇట్ ఈస్ సేమ్ అండర్స్టూడ్
Yes, sir.
ఒకటి ట్రై చేయి.
So instead of the rings, I have to write directly pH, right?
Yeah, your wish, you can do that. You can write like this, or you can just put pH. It's up to you. Mandara, yours is correct.
Thank you, sir.
Japna, Shrikar.
Yes, sir.
So see here what happens. The pH C is to CS3. Now I am removing two double bonds. So I'll be putting here hydrogen. So I should decide whether I should put H2 and double bond O on which carbon. So if you see here, this carbon, it is only having two carbons here. But if you see this carbon, it is having the benzene group, which is a 6-carbon heavier group. So this is a heavier group and this is a lighter group. So I'll be putting double bond O here and I'll be putting hydrogen here. That's it. That's the answer.
I almost got it correct. I didn't attach hydrogen.
Okay. So actually how this reaction will happen? This reaction will happen like this. PHC. So there will be attachment of hydrogen here and it will convert into double bond and there is a OH here, CS2, CS3. This will be further followed by PH, carbon. Now it will get hydrogen from this oxygen. So that hydrogen will attach here and C, there will be oxygen O minus, CS2, CS3. Now it will go here. So PH, C, hydrogen, hydrogen, C, double bond O. Sorry, I told you reverse. So this is OH, this is hydrogen. This is O, this is hydrogen, O minus. Double bond O, H2, CS2, CS3. Understood?
Yes, sir.
Okay. So we'll wind up here. Let's call off the day. Okay then. Good night, guys. Prepare well for tomorrow's exam. All the best.
Thank you, sir.
Thank you, sir.
Good night. Bye bye.
Yes, sir.
చదవరా సరిగ్గా